Hai, Assalamualaikum and good day everyone. So for this video, kita akan tengok preparation of amine. And here are the learning outcome. So at the end of this lesson, you should be able to know the reduction of nitro compound, reduction of nitrile compound, reduction of amide, and also Hofmann's degradation. And kita akan tengok synthesis of primary, secondary, tertiary, and also aromatic amine. Okay, so basically this is the summary untuk preparation of amine. So you have reduction and also Hofmann's degradation. So untuk reduction of reduction, kita ada reduction of nitro compound. So nitro with NO2, reduction of nitrile compound with R ada CN. And the reduction of amide. Amide tu kalau kamu ada R bonded to C, double bond O and H2. Okay. Alright, so first kita akan tengok reduction of nitro compound. So untuk nitro compound, the reagents are zinc with H plus acid, SnCl2, H plus, Fe, H plus. So you can use either one. And biasanya nitro compound, aromatic nitro compound, kamu akan dapat aromatic amine. So these are the example. So you have here nitrobenzene, and then you react with zinc, and then you have H plus ataupun hydrolysis. Right, so from this part, nitro, basically reduction of nitro compound ni, it's just when you have NO2, you akan gantikan dengan NH2. Okay, so daripada nitrobenzene, dia akan form this aniline. So if you have two substituent dekat sini NO2, 1,2-dinitrobenzene. So you react with the reducing agent, either one. Okay, so you react with the reducing agent, and you akan form benzene 1,2-diamine. Okay, so ini NH2, dia akan ganti dekat position NO2 just now. Alright, so next kita tengok reduction of nitrile compound. So reduction of nitrile compound, this one we have seen before, and we can use reducing agents such as hydrogen with metal catalyst ataupun lithium aluminium hydride followed by hydrolysis. But it is better for you untuk guna ini sahaja. Okay, so kalau soalan tak spesifikkan, you just use this one, because untuk hydrogen and metal catalyst, it is a very strong reducing agent. So sometimes kalau ada C triple bond C, C double bond C, okay, C double bond C, dia boleh reducekan these two juga, and carbonyl. Okay, so untuk this example, if you are using this hydrogen and metal catalyst, okay, C triple bond N ni ataupun CN, nitrile compound ni, dia akan jadi CH2 and H2. Dia akan form primary aliphatic amine. Okay, so let's see here. Let's say you have this structure of nitrile compound. So untuk reduction of nitrile, basically you just change dekat bahagian CN, dia akan jadi CH2 and H2. Okay, so the rest of the carbon chain is still the same. Right, so next let's have a look at this cyclohexene with CN. Okay, so untuk this structure, this compound, kalau kamu undergo reduction with lithium aluminium hydride followed by hydrolysis, kamu akan tukarkan CN jadi CH2 and H2. So dia akan jadi primary aliphatic amine with reduction of nitrile. Okay, so next kita akan tengok reduction of amide. So untuk this one, reagent dia adalah lithium aluminium hydride and then followed by hydrolysis. Okay, so you can write this part sajalah. Okay, mesti stepwise. So you must write stepwise 1 lithium aluminium hydride and then followed by hydrolysis second step. So amide is when you have C double bond O and then NH2 bonded to alkyl group. And then when you react with this reducing agent, you can form primary amine. Okay, sebab basically this C double bond O, dekat bahagian C double bond O sini, dia akan jadi CH2. And then the rest of your carbon chain tak ada perubahan. You just write semula, exactly the same. So dia hanya ada perubahan dekat the C double bond O jadi CH2 sahaja. Let's have a look at this example. Kalau kamu ada this general equation secondary amide and undergo reduction with lithium aluminum hydride followed by hydrolysis, kamu akan dapat form secondary amine. Okay, basically C double bond O akan jadi CH2. So kalau tertiary amide, kamu akan form tertiary amine. Okay, now let's have a look at this example. So kita fokus dekat C double bond O. When you undergo reduction, oksigen akan hilang, akan ganti dengan 2 hidrogen. So the rest of the compound tak ada perubahan, you just tulis semula NH2 and then CH3 CH2. Okay, and then the next example sama juga dekat C bahagian C double bond O. At C double bond O kamu akan dapat CH2 and then the rest of the compound is still the same. Right, now kita tengok Hofmann degradation of amide. So untuk this one, dia punya reagent adalah Cl2 or Br2 in base such as NaO ataupun KOH, potassium hydroxide. Okay, so the product will be primary aromatic amine ataupun primary aliphatic amine, depends on the reagent that you react with. And what happened here, C double bond O akan di-remove. Okay, so kamu akan dapat just this structure. Okay, basically kamu buang this C double bond O. And bila kita guna this reagent ataupun kita buat this Hofmann's degradation of amide, basically we are reducing the number of carbon. We can see here, sini ada carbon, sini carbon tu hilang. So okay, now let's have a look at this example. Let's say you have this amide, aliphatic amide, and then kita react dengan the reagent Cl2 and NaO. So kamu akan dapat this part of your C double bond O akan di-remove. So you akan dapat CH3 CH2 and then directly bond to NH2. So you can see that we lost this C double bond O. So that's what I meant just now. Kalau kita buat Hofmann degradation, kita akan kurangkan number of carbon. So number of carbon kita kurangkan. So now dekat reagent dia, we have 3 carbon. And bila kita buat the reaction with Hofmann degradation, this reagent Cl2 and NaO, you only left with 2 carbon. Okay, so kalau soalan sintesis yang melibatkan pengurangan bilangan carbon, you can use this Hofmann degradation ataupun you can also use iodoform. Okay, iodoform punya reaction. So itu je yang boleh mengurangkan bilangan number of carbon. Alright, so next let's have a look at this example. So ini ada C double bond O dekat sini, kita akan removekan dia. So your final product will be this aniline. Okay, so kamu akan form this aniline from this amide. So let's have a look at this example. So untuk this one, kita ada C double bond O dekat sini. And you akan remove this C double bond O because we are reacting with this reagent Cl2 and strong base KOH. So kita akan eliminate the carbonyl C double bond O and you will shorten the carbon kurang dengan 1 carbon. So you will get this product. Okay, so dekat reactant kamu, you have 1, 2, 3, 4, 5, 6 carbon. And for your product, you only have 1, 2, 3, 4, 5 carbon. Okay, so kita nampak pengurangan number of carbon here. It will decrease ataupun shorten the length of the carbon chain by 1 carbon. Hanya 1 carbon saja yang berkurang because we remove this C double bond O